Building a theme for the XOOPS content management system usually means building a monolith. You start with a single file, and over time, it becomes a massive, rigid structure that collapses under its own weight. The symptoms show up in the template files. You find hundreds of lines of inline PHP mixed with markup. You see duplicated menu logic, massive include blocks, and global variables scattered everywhere. Because layout, behavior, and presentation are tightly bound together, changing a simple CSS class can break the navigation system entirely. Every theme breaks independently because every theme author reinvents the same boilerplate. Fixing this requires separating the presentation layer from the underlying logic, but it has to be done without abandoning Smarty. Smarty is the core templating engine that natively powers XOOPS. Relying on these legacy templates means developers spend most of their time fighting the infrastructure instead of designing the presentation. The ecosystem becomes impossible to maintain. The XOOPS theme framework replaces ad hoc PHP with strictly typed services. It handles layout slots, design tokens, user preferences, and dashboard widgets. Instead of writing code, XTF relies on a declarative architecture. A single configuration file handles the execution. That configuration file is the theme.json manifest. It acts as the single source of truth, centralizing the layout structure, visual tokens, and user preferences into one readable format. By moving these definitions into the manifest, the HTML markup is completely decoupled from the PHP processing logic. The template files only handle the visual output. This architecture applies symmetrically across the entire content management system. The front-end presentation and the back-end admin environments run on the exact same framework rules. Moving configuration into a central manifest limits the surface area for bugs. It locks in a stable identity for the theme and makes customization safe. Look at how layout extraction works in practice. We remove the deeply nested HTML structures and manual file includes that usually clutter the main template. Instead, we define named regions in the manifest, like the header, content, and sidebar. A service called the slot renderer reads these definitions. The slot renderer takes over the page composition. It automatically reads the manifest and slides focused partial templates directly into their designated slots. These slots can be bundled together into groups. This allows developers to compose complex, multi-column layouts by wrapping regions in specific HTML containers, all without writing any structural PHP. To maintain backward compatibility, legacy XOOPS block zones, like canvas left or page top right, are mapped automatically to these modern slot names. Page composition is no longer a brittle coding exercise. It is a predictable configuration task. Traditional themes suffer from CSS drift, where layout dimensions and specific hex colors are hard-coded across dozens of disconnected style sheets. Updating a brand color requires finding and replacing it in 50 different places. XTF centralizes all visual variables into a design tokens object inside the manifest. You define your primary color, spacing, and typography exactly once. The framework reads these JSON tokens, converts them into CSS custom properties, and injects them directly into the page header at runtime. Because the values are controlled by CSS variables, features like dark mode work natively. You just override the variable values for the dark theme rather than maintaining a completely separate overlapping style sheet. This also powers the customizer UI. Administrators can use a visual color picker to adjust these tokens. The new values are saved directly to the database and override the defaults instantly. This hands visual control back to the designer and mathematically prevents the CSS from degrading over the theme's lifespan. Managing user settings traditionally meant reading raw global variables or scattering cookie checks throughout the template. XTF structures this process. It introduces the Preferences Manager, a centralized PHP service dedicated solely to handling user overridable settings. When a user loads a page, the Preferences Manager resolves their settings through a strict cascade. It checks for a user-specific database row first. If that is empty, it falls back to the site-wide database row. And finally, it rests on the theme manifest default. This cascade scales. It can operate on simple, stateless browser cookies, or it can upgrade to fully persistent database-backed storage, depending on which tier of the framework is active. The preference cascade isolates the theme's presentation from its data persistence. User personalization is kept separate, scalable, and safe. To see how this architecture impacts external developers, look at module integration. There is usually high friction when trying to build uniform dashboard widgets. The dashboard widget discovery system automatically scans the active module directories for a single PHP file. No manual registration is required. The developer implements 3 simple methods, and the discovery system instantly wraps that file into the robust XMF rendering pipeline for structured data output. Entering this pipeline provides immediate benefits. The widgets inherit strict error boundaries. If one module's code fails, it is silently skipped. A single broken module won't crash the entire dashboard. The pipeline natively handles caching the widget data, sorting the widgets by priority, and formatting them into a unified card layout. By removing the integration friction, module authors can deploy dashboard widgets safely and instantly without having to write theme-specific code. Zoom out to look at the entire XTF lifecycle. Data moves logically from static configuration files all the way to the final rendered output. The primary layout path begins with the manifest data in theme.json. That data is parsed by the theme manifest, passed into the slot renderer, and finally delivered to the Smarty templating engine. The secondary path handles customization. The customizer service coordinates user preferences and design tokens, translating them directly into live CSS output. The tertiary path manages the marketplace. The widget catalog pulls available components, and the slot placement manager organizes them into fully assembled dashboard widgets. All 3 of these paths operate simultaneously. They are seamlessly coordinated behind the scenes by strictly typed PHP services. Because the data flow is strictly segmented, the framework can scale progressively across its 3 tiers, from basic scaffolding up to the visual customizer, without ever altering the underlying architecture. This linear, predictable pipeline keeps the architectural complexity low, minimizing the risk surface of every single theme modification. This framework runs on strict modern standards. It demands a high level of code quality, utilizing static analysis, automated testing, and the performance upgrades of PHP 8.4. But XTF is not a disruptive rewrite that forces you to abandon your old work. It is a stable ecosystem designed for gradual adoption alongside existing CMS infrastructure. Ultimately, this architecture aligns the entire development workflow, creating a unified, collaborative workspace for 3 distinct technical personas. Designers gain a strict tokenized visual system. They control the entire visual language of the site without ever having to write or debug PHP plumbing. Theme developers and module authors gain a library of reusable, strictly typed services and a frictionless integration layer. XTF turns themes from fragile, ad hoc template files into a resilient framework. It permanently restores software engineering discipline to the presentation layer.